Why are variational autoencoders probabilistic? Imagine trying to recreate a complex painting with just a few brushstrokes. Variational autoencoders do something similar. They learn to generate new data by understanding the underlying patterns. Unlike simple autoencoders that compress data into a fixed point, variational autoencoders use probability to capture the full picture. They don't just remember one way to recreate an image or text. Instead, they learn a range of possible ways, which makes their outputs more flexible and realistic. The key reason they are probabilistic is because they model data generation as a process involving chance. When the encoder processes an input, it doesn't produce a single fixed code. Instead, it creates a probability distribution, usually a Gaussian or normal distribution, that describes many possible codes. Think of it like a cloud of points rather than a single dot. This distribution is defined by parameters like the average or mean and how spread out it is, which is called variance. Then, the decoder takes a random sample from this distribution to generate data. This sampling process is what makes the model probabilistic. It means each time you generate something, you might get a slightly different result, reflecting the uncertainty in the data. This randomness allows the model to produce diverse outputs, which is especially useful in creating realistic images or text. The reason for using probability is also to make training easier and more stable. During training, the model learns to shape these distributions so they stay close to a known, simple distribution, often a normal distribution. This is done through a technique called variational inference, which helps the model balance how well it reconstructs data with how closely its learned distributions match the prior. A clever trick called the reparameterization trick makes this possible. Instead of directly sampling from the learned distribution, the model samples from a standard normal distribution and then shifts and scales the sample using the learned mean and variance. This way, the process remains differentiable, allowing the model to learn through standard methods like backpropagation. In the world of artificial intelligence, models like ChatGPT, DALL-E, and Midjourney use ideas from variational autoencoders to generate content. While they may use other architectures, understanding VAs helps explain how AI can produce diverse, realistic outputs by capturing uncertainty. From an ethical point of view, the probabilistic nature of VAs also means that the data they generate depends heavily on the learned distributions. If these distributions are biased or incomplete, the outputs might reflect those biases. Ensuring that the model learns fair and balanced distributions is important to avoid unfair or inappropriate results. In short, variational autoencoders are probabilistic because they representing data as a range of possible codes, not just one fixed point. This approach allows them to model uncertainty, generate varied outputs, and be trained efficiently. Their probabilistic design is a core part of how they help machines understand and create complex data in the field of deep learning and specialized artificial intelligence.